So we're in the middle of rewinding this stator to be south, south, north, north. But these are dual strand. So I'm not sure exactly how I'm going to do this yet. But I also just realized I need to, as I unwind this, I need to count to figure out how many turns are on each one of these. So it turns out these fans, there's lots of different kinds, right? There's infinite makes and models, right? And some of them are harder to take apart than others. But anyway, this is the one that we took apart from this this here. Okay, so there it is. Dusty's from an old mining rig. Look at this. The good old days. Ethereum mining. Anyway, back to this. So what we did, took this apart, and it's neat. The construction of this is neat. That's a ring magnet. North, north, south, south. And so that's the motor driver inside of it. And the bearing there. And so actually rewired this one as well. This has got some torque to it. So anyway, that's where we're at. Oh, and here's the wire. So I unwound this, about 117, 118 turns, and there it is all. And then there's this guy here too. So 7490 Hall effect. So I'm working on explaining this, but I got this, but I don't have any batteries for this. But I think I'm just gonna try to take it out of the case and just maybe use it that way. I'm not gonna take this thing apart. I'm just gonna clip on, right? But I don't wanna break anything, so. But yeah, so it's 5 volts. When the button's pressed down, 8 milliamps. When it's beeping, it's 27. And then interestingly, see, I assumed that this magnet was north, north, south, south, but it's not. It's so that's south, right? Off, north, south. You know what I mean? It's just north at the top, bottom, south. So good. Glad I checked that. All right. So like I said, this is diametrically magnetized, so it looks like this. So one half of that ring in here is north, the other half is south. It's like this. And so the best way to think about how to wind this is the right-hand rule, right? So you have the green here for the current, right? That's the direction of current flow from positive to negative, right? So we always know that electrons go from positive to negative, so we do this here. So if we have a coil of wire, even clockwise or counterclockwise, that doesn't really matter. What matters is the positive or the negative, right? Well, where the positive is, and that's the point of what I'm trying to say here, is if you go like this, right, that is the north-south polarity, and then if you put positive here, right, so that's what I'm saying. If you put positive here, so that's what I'm saying. If you put positive here, just as a side note here, this is a comparator circuit I made. So I lasered this up. LM393. So just quickly go over that. Number one thing. Number one, op amps are not comparators. Okay. That's number one. Because for usually what you're trying to do is dump a cap or compare voltage or whatever, right? So, you get an LM, you get whatever one you want. 393. Okay, and you get your, everyone knows that, right? So what you do, depends on what your input signal is. In this case, this is the this is 400 millivolt, right? That's what this generates for the trigger coil, right? So what you do, say you use 12 volts here. So you just set up 2 dividers, like this. Okay, 10K, 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 and 10K. Right, so there you are at 6 volts. Right, maybe you have some series resistance here or whatever. Okay. Trick is this signal, you're like, okay, well, if this is 6 and this is 6, depending on which one I connect these to, I'll get my output, right? 0 volts, 12 volt. Well, yes, but what you have to do is you have to do this. I don't really know what value, it just depends on what frequency, but 1 UF or like 10 or something, whatever. Then, right, that drives it. And a perfect test, you have a good comparator when you have the chip powered up and everything, your dividers are there. You don't have an input signal, but you take a voltmeter and you measure your setup voltages here. Your output triggers because the meter does the same kind of thing here, right? So this is a really good way of making, and you could add this and that, decoupling and all this, maybe I don't know if you do feedback on this. Anyway, that is useful for people, right? And so now I'm just getting the wire off of those posts there. A little better shot here of how fine the connection is. Yeah, pretty funny. So I went to go try to use this to record, taking that off there. This is just toasted. It's not doing anything, and you can't even get into the menu to try to say it could use the backup battery, but the power is disco, and we're just going to have to let the battery run out, and then I got to do this. It's actually not too bad. Light on it. There's this guy again. Pretty sweet. And so we're just measuring the resistance of each wire. So the red wire 14.2 to 14.4 ohms, gold wire 14.1 to 14.2. So now that I'm ready to wind here, I just got this on the side of here so it'll spin better. And then I'll just put it on the floor like so. Right, and then it'll just spool off of there nice, and then I can just hand wind it. And I gotta count 117 turns. Then I gotta do 1 and then test it and see which way the field is. I never did explain why the cap needs to be here. It's because if you have your divider, you have the cap here. This is 6 volts, right? And so when you're doing this, and then say you're here, right? This node here should be like 6.4, right? But what happens is, okay, to demonstrate this properly here. So, right, we have this going on, right? We even have, those are just both going to ground, right? And we have this, right? These are both 6 volts. But, you've got your magnet going by here, right? And you got your pickup coil. Just do it this way, I guess. Okay, that's your pickup coil, right? So one side does just go to ground, right? And the other side goes here. Well, you're just shorting it. Like say, you know what I'm saying? This would need to be 10K, this would need to be 10K, right? And if you add this with trigger coil or whatever, well, in this case, like 14 ohms, right? That loads, it loads the input is what it's called, right? And because it's an AC signal and because it's changing, it'll pass through the capacitor, right? You know, as we go positive, this is positive side, then negative side, and as we go negative, this is positive, this is negative, right? And it goes back and forth, right? So, but it isolates electrically, right, the input, right? So that's how that works. So that's why you put it there to, it's really just decouple. It's just like an audio thing, basically. All right, so I'm ready to wind 117. I got the first one soldered on here. All right, so it's fully rewound. And I just got the hall sensor right here. Figured out which pin's VCC, which one's ground. I'm gonna scope the other two. I'm gonna laser a board quick to break this out. So here's the board that I lasered up to get the Hall effect on there. And then I just plugged it into a breadboard here. And then I'm not really sure why this is blinking sometimes, but when you do this here, this way, see? See, there you go, right? There's your trigger. So basically the summary is the goal has been to build a Bedini fan. What I did first was I rewired this guy, okay? The trigger coil, when you hand spin it, makes 400 millivolt peak, okay? So it's workable, right? Which is why I built this, okay? Which the comparator side worked, okay? And lights the neon and everything. But this drive stage caused failures, right? So there needs to be isolation here, okay? And then I also reverse engineered the Hall sensor off of it, right? So, you know, what we found is, you know, if you're trying to run it like a typical Bedini, this didn't, because these, I can't take this apart right now, but these are low resistance. These are like 1 ohm. Okay, so you can see how there can be lots of design variations even in a small package like this, right? So anyway, oh, and then another amazing thing. So this is an H bridge, right? Well, see all those diodes? Instead of those, see, and look, they go right back to, watch this. See, this is the flyback diodes. They all, look at all these lines, right? They go through here, 12 volts. So guess what? Snip, sand some of that away, solder on some copper here, thicker copper. Like I have some copper foil, like, right? And all of a sudden that's your open, right? Perhaps. Gotta look at this data sheet. See what this thing is. L298N. These are 12 amp, 100 volt Darlingtons. Right. So, which, by the way, January 2026, they were $1.07 a piece, $1.07. Now it is July 2026. They're over $3 now each. So anyways, yeah, the comparator worked, that worked. I understand the windings, but I think I know enough now. Like, I've done enough R&D to actually plan a project build for this. And that's probably what we'll do now.